So we mentioned in the last video, we started talking about what a confidence interval is, and then we left off with these critical values. So the three most common critical levels of confidence are 0.9, 0.95, 0.99, and that corresponds to 90%, 95%, 99%. And so our critical values are there. Now, if it's not one of these, we can still find what the critical value is using our inverse norm. So inverse norm. And remember, you find that by hitting your second, and then you hit the vars button to get your distribution. And we'll go through our next example. We'll actually go through and find the critical value. So it says for a confidence level of 88%, find the critical value. So the way confidence intervals are, it's sort of helpful to draw a picture, right? So here's this, right? We know sort of the mean, right, would be right in the middle there. So 88%, we are looking, right, for 88% of the curve. So sort of this confidence level, right? So that's 88%, right? So 88%. And so what we want to find these critical values. So negative Z of C and positive Z of C. So what we want to do, right, is find the area. Let me change the color. We want to figure out what is this little piece here. So you can actually find either piece. I'll sort of talk about both, but so if I think, right, so we know with our curve it's a total of 100%. So I could take, right, 100 minus the 88, right? So 100 minus 88, right? So 12. Now as a decimal, right, 0.12. And if I divide that by 2, right, and you can think we divide it by 2 because we have two equal tails, right? So if I have 0.12 and I divide that by 2, right, I get each of these little pieces, this pink, let me go here, pink, right? So 0.06 and 0.06. Now, inverse norm, right, takes the area that you have and finds the corresponding z-score. So if I try to find the lower value, I could do inverse norm of 0.06. I'd have 0, right, for the mean, and the standard deviation would be 1. So if I hit second and vars, and I go down to inverse norm, which is number 3, the area, right, is going to be, let's see, 0.88, mu is 0, oops, sorry, let's see, 0.06 for the area. Mu1 tail, right, you can do left, we're looking at this piece here, we're going to paste it. So we end up, right, with a negative Z of C as negative 1.55, right? Okay. Now, that's the lower one, right? So if you want to do the positive one, what you can do is think about what is the total area. So I'm going to do this in green. So if I think all of this here, right, would basically be the area we want to put in for the inverse norm. So I would do, I could do, right, 1 or 0.1. I could do 1 minus 0.06, which would be 0.94, and I could do that for my inverse norm. Inverse norm of 0.94, 0, and 1. So again, if I hit my second vars, go down to inverse norm, the area is now 0.94. It's still, right, mu1, tail left, paste it, right, you end up with positive 1.55, which makes sense, right? So you'll notice our critical values, the only really difference between the numbers is one's positive, one's negative. So if it just asks for just a critical value, we usually give the positive critical value. So we would say 1.55. All right. So just to note, with some of the older calculators, they don't give you this option of left or right. It's sort of always defaulted to left. So you just want to put in here what I have here, the 0.94, 0, and 1. Now with this calculator, what's nice is if you have this newer version, if you go to inverse norm and you do the area, you just do the 88% and you tell it to be in the center, it's going to give you, you can see here, it's going to give you both of them at the same time. So if you have the newer version, you don't actually even need to do all of this sort of shading. You can just say, hey, it's in the center, find the critical values. But I have the older version, and so I just wanted to make sure you could still go through and find those critical values, okay? So as we go through and do some more examples, we'll sort of do this and calculate this, the critical value, as one sort of step, one part of the problem. So let's take a look at our sort of first formal example of a confidence interval. So it says a quality control specialist for a restaurant chain takes a random sample of size 12 to check the amount of soda served in the 16-ounce serving size cup. Assume the population standard deviation is 1.55 ounces and that the population is normally distributed. If the sample mean is 13.3 ounces, find a 98% confidence interval around the population mean amount of soda. All right. So let's just take a look and write some things we have, right? Sample size is 12. Population standard deviation is 1.55. Sample mean, X bar, is 13.3. And our confidence interval is 0.98, right? So what we're trying to find, right? We're trying to find this interval. So X bar, right, plus or minus the margin of error. So I have the sample, right? I have the sample mean. So it's really just that margin of error that we're trying to find. So one of the other things to note is since I have the population standard deviation, right, we're thinking a z-distribution. And you'll notice they do tell us the population is normal, so we're good to use a z-distribution. So sometimes we might have to check, is it a z, or eventually we'll check to see if it's a t. So this one is a z because we have the population standard deviation. All right, so my margin of error, if I write what the formula is, and this is above, it's, right, the critical value times the population standard deviation divided by the square root of n, which is the sample size. So what we need to find really is I need to find my critical value, right? So I can draw my little curve here, right? And we're looking at 98% in this case, so it's most of the curve here, right? So 98%. And so we're finding, right, the lower value and the higher value of my critical value. So if I do, right, so 98%, so 1 minus 0.98, I converted the 98% into decimal, right? So 1 minus 0.98, right, is 0.02. And then I'm going to divide that by 2 so I can get what's actually in each of the tail, right? And you should get 0.01. So 0.01. So if I'm going to shade a different color, right? So this is this little piece, 0.01, 0.01. Okay. So now we're ready to find, right, use our inverse norm. So inverse norm. Again, I'm just going to write sort of the older model. If you have the newer one like I have in my emulator, you can just do the center and do it as 0.98. But I'm going to do 0.01, 0, and 1, right? And this is going to be to the left. So second bars, go down to inverse norm. Area is 0.01, 0, 1, and it's going to be to the left, and paste that. And so I end up, right, with a critical value of, so negative 2.326. And so what I'm going to do is just for the critical value, I could recalculate it, but I know it's going to be the same thing, just a different sign. We're actually going to use the positive critical value when we figure out the margin of error. So we'll use that 2.326. Okay. So if I want my margin of error, let me write it over here. Right, I have 2.326. times the standard deviation, so 1.55, divided by the square root of 12. So I have 2.326 times 1.55, right, divided by your square root of 12. Okay. So I have my margin of error is 1.041. Okay. Now I'm ready for my confidence interval, right? So x bar, right, plus or minus the margin of error. So x bar is my sample mean, which I had as 13.3 minus 1.041, less than the mean, less than 13.3 plus 1.041. So 13.3 minus 1.041. So I have, and I'll write it as an interval, 12.259. And I have 13.3 plus 1.041. So 14.341, right? It didn't really say where to round, so I'll keep it. I might round to 2 decimal places when I'm making my interpretation. But this is my confidence interval, right? So what I can say now, right, we can say with 98% confidence, we can say that the amount of soda in a 16-ounce serving cup size cup is between, so I can say 12.26 ounces and 14.34 ounces. Okay, so we usually say how confident we are, right? So with the 98% confidence interval, and then we can just sort of say what we actually found. So we're talking about the soda and what we found. So you might be thinking this is a lot of steps, right? And they're not difficult. There's just a lot of little ones that we have to make sure we go through. So what you can actually do is if you go to your calculator and you hit stat, so I'll write this in pink. So stat, and you scroll over. Oops, my calculator's not scrolling. To tests. And with this one, right, we're doing a z-test. So we want a z-interval. And hit enter. We have the stats, right? Our standard deviation is 1.55. Our sample mean was 13.3. Sample size was 12. Level of confidence was 0.98. And we want to calculate this. You will notice that what it calculates here is actually what we calculated here. So if the question just wants the confidence interval, you can actually sort of bypass all of these steps and just plug it into your calculator and find that interval. Now, if it wants specifically like the margin of error, then it's, easy. You can go through and sort of calculate it by hand here, okay? So that is our first example of how we can find a confidence interval.